So this is the code for the accelerometer. So this experiment uses LCD to display the values. So that is why there is a library for the LCD. But the important uh, libraries are this four: the wire.h, Adafruit sensor, the Adafruit ADXL345 under U, and the servo library. So since the experiment demonstrates how the how the accelerometer controls the servo motors. So as we can see, we declare the servo motor objects which named as servo X and servo Y. For servo for x-axis and the servo for the y-axis. Then these are the variables used. We can discuss these variables later, or how these variables used in the code. So let's go to the void setup. So as we can see, we initialize the LCD and we turn on the backlight, and this one is initializing accelerometer, and we can see it is in an if loop to detect if the sensor is being detected by our Arduino. And this one are the pins where the servo motors are attached. As we can see, it is attached on pin 9 and pin 10. For the void loop, so this is detecting accelerometer values. So we can see we get the sensors that underscore event t event, in which on how when the accelerometer moves on a certain axis, and then accel get event under ampersand event. So when the motion is detected on that axis, the accelerometer should get the value of it. That is why there's accel that get event, ampersand, and event. So x is equal to the event acceleration dot x. It means that it only x is equal to the values of the accelerometer on the x-axis, while the y is the same but with dot y, event dot acceleration dot y. It means that the y is equal to the values of accelerometer on the y-axis. So for the map values, this is the map values for our servo motor. So we can see we map the x values that is ranging from -20 to +20 with 0 to 179 degrees, since our servo motor only do 180 degrees, while the value y is with the same range from 0 to 179, but instead of x we use the value of y, or the values along the y-axis. So going here, we can see this portion of the code is where we display the values of the sensor. So we can see that we print the value of the x, which is this one, and we print the value or the map value, which is served as the angle. The same thing here with y, value of y, and the angle that is equivalent to the values of y. So this is the positioning of servo motor, where the right function will move the arm of the servo motor on a certain angle in which it is detected by the accelerometer. This is for the x-axis, and this one is for the y-axis, and it has a delay of 15 milliseconds. And this is the code for the accelerometer itself, and we will try it to our circuit. So this is the circuit of the servo motor controlled by the accelerometer. So we can see we use an LCD to display the values of x and y and its equivalent value to the angle of the servo motors. So we can see that we use the ADXL345 as the sensor for or the accelerometer itself. So this accelerometer is a 3-axis accelerometer which detects the x, y, and z direction. For this experiment, we use x and y since we have only 2 servo motors. So as we can see, this is the x. We can see it is in 98 degrees, and if we lift it back, we see it's 4 degrees, and turn it back. So we have around 129 degrees or 130 degrees. So if in this side, this is the y direction. So as we can see, there is 107 degrees, and if we back, it's around 50 or 49 degrees. So as we can see, if we move the x-axis, this one of the servo motors, this one is created a bigger movement, while the y-axis, the other servo motor created big movements. So this is x, and this is y. So this one creates a bigger movement for the y-axis, and as we can see, we use only 4 pins since this is the required pins for our code. Hope you like this video, and see you again next time.